Hey everybody, Adam Savage here in my cave with a really fun one-day build today made possible by Autodesk and Lucasfilm. The upcoming Star Wars series, The Acolyte, which starts premiering on Disney Plus on June 4th, will introduce the world to Pip, a handheld repair droid designed by special effects legend Neal Scanlan using Autodesk's Fusion software. To celebrate Pip's debut, Autodesk and Lucasfilm are teaming up for a droid design contest. Fans can submit their own droid designs to autodesk.com/droid for a chance to win prizes, including a trip to Lucasfilm headquarters here in San Francisco or the Walt Disney Studios lot in Burbank. I am going to be spending this build designing my own droid and using Fusion software to execute it. Let's get to the build. In the interest of bounding this problem to something that I can execute in a day, I'm already beginning by thinking small. I'm thinking even smaller than a mouse droid kind of droid, but so I'm thinking about something about this big. Here we go. I am just going to try and start iterating some shapes here. I'm interested in silhouettes. I'm interested in lines of convergence and sort of trying to find a character within them. That's the first goal of sketching. Once I have some ideas laid out, they'll start to reveal, I think, a form. I am definitely thinking of a two-wheeled small droid in which the wheels are the only things touching the ground, just two wheels, like a self-balancing something or other. So I've got a kind of design idea I like, which is of this sort of long-faced mini droid who can extend on a pair of tires. So he can ride up and high, or he can ride low and hide. And he's also got I like this idea that he's got a little jet engine, so he can like speed up if he needs to. I like these wheels. I just started to draw wheels on a camber here, and I really like them. I think that this droid is relatively untippable. So I've given the tires sort of round hubcaps, so the idea is like you can see that if you kicked him, he would just land on his feet and keep on going. Yeah. And this all seems like it would work. I don't know what this face looks like. It's really, I don't know. It's like always a mixture of some big lenses and small lenses. But I like the idea of the face as this set of gentle curves. Like it's what do you call it? It's trapezoidal, but all four sides are curves. That's like feels like a Star Wars inspired droid face. All right, let's try this side elevation here. It's like if you cut through, oh yeah, that's nice. Maybe a little gentler here. This kind of sketching is, I've only really felt like I am even roughly competent at it in the past few years. It's like I spent my whole life sketching, but only recently does my line feel like it behaves. Let's see here. A little like afterburner here. I'm also taking some inspiration from having worked extensively with Nilo Rodis-Jamero on Home Alone 3. From a design perspective, I get to really see how he finds his way to a design, hiring several designers for like a solid day of work, all of them iterating repeatedly, no design looking like any other. But by the end of the day, he has enough of a sort of spread spectrum approach on design that he can start to sort of tease out what the actual details would be. And that really helped me as a young designer realize that like, I don't have to be able to picture a full design in my head. I can just keep drawing shapes until something becomes apparent to me, until like an idea or a theme starts to shake itself loose. All right, and I think the wheel here, this is actually almost bigger than full size. The wheel is like, yeah, it's like that. All right, I feel like I have enough of an approach to this design that it is time to move to the next step, which is to translate this into Fusion. Now, I have done, weirdly, a large amount of CAD in my past, but I am nowhere close to an expert. And I'm bringing in the expert. My friend Bill Doran from Punished Props is a Fusion whisperer, and I'm going to send him all of the drawings I feel like are of the similar droid. And he is going to kick out the first drawings of an actual 3D execution of this. Bill.
Hey, happy to be back in the cave.
Dude, it is so good to see you.
Yeah.
This is really interesting for me because I've spent so much of my life receiving sets of drawings from art directors and executing them, but I have very rarely been the art director. And so after drawing a bunch of these drawings, I'm really curious what your process is for breaking down what I sent you.
Sure. So I'm glad that you did a full-on orthographic side view and front view.
Yeah.
Right? And even if they're not
They don't
precise
quite
to one
match.
another, that's fine, because I can set that up in the computer orthographically and start working from there.
Oh, so you like set up a plane of my drawing and start tracing right against it.
And so the right here, 3-inch diameter on the wheel,
Yeah.
right? That was my one scale reference. So I chucked the drawing.
Yeah,
side
that's
view,
I think this one. Yeah.
right? I chucked it in there, and in Fusion you can calibrate your canvas, this image, and I just clicked on one side of the wheel, clicked on the other side of the wheel, and I typed in 3 inches, and it scales it for you.
That's
So no matter where it is,
really
it
cool.
just that's how big it's going to be. So if I'm making a costume piece or something like
Right.
a helmet, I can take a known dimension off of a thing and immediately set it up that way.
That is really nice.
And then I also got the front view, and I laid that on the front.
Look at you.
Yeah. So
All of a sudden it starts to have a form factor.
it does, even with just the two planes, you can see how I line them up so that they intersect correctly.
Yeah.
And from there, I can start drawing out the three-dimensional bodies.
Yeah.
So for the main sort of outer cowling on that right there, that's kind of where I started to start blocking out the forms. I can just basically on the front view use a sketch to draw the front of it there. Sketches.
Oh.
So like this here, if I had the bodies,
Yeah.
this is the sketch I made of that front view right there.
Right.
These lines right there. So that can get extruded or lofted to make a 3D form.
Right.
And then I did the same thing on the side view to cut out like this cut. Oh, this is a touchscreen. Look at that.
What?
I never used that feature. So basically, I was able to cut out that form from the side view, and you can see how that lines up with your drawing.
Right.
I did also, I scaled this a bit, so it's not quite lined up anymore.
No, I mean, look, the whole idea was, to be fair, I always understood that when an art director gave me drawings that didn't match, he was asking me to solve the problems about where the matching happened. And so I felt totally comfortable knowing your skill set that like, none of these had to be exactly right, but you would understand the gesture. And that is super cool.
And then at a certain point you said, boy, things would look cooler with panel lines. And I was like, you got it. So I added panel lines to the cowlings. Each section of the drawing is split up by different components here. So I have the main body part here.
So you didn't draw this as a single monolith. You drew it as separate parts.
Lots of separate parts. And while I was drawing each part, I tend to work on the hardest thing to solve first. So the wheels, we're going to have a suspension.
Right.
Even though you said, it doesn't necessarily have to move. In my brain, I said, it's going to move. It's definitely going to move.
I knew that too.
Yeah. So this chassis does a lot of the heavy lifting there. If I hide the main body. This chassis here has...
Oh, look. The 2 pins for the parallelogram.
There you go. Springs go in the top there for a lever on the top strut so that it's got some sort of a suspension. And I worked on this first and just the struts. Actually, I only did half of it.
Right, of course you did. Yeah.
And I printed test pieces to make sure that the functionality would work before I mirrored it or before I added any of the greeblies or anything to it.
And I think people who don't do 3D printing or who are thinking about doing it think of it as probably a long process, like it's going to take a few hours to get your print, but that's not the case here. You're able to see a physical version of what you're drawing in like half an hour.
Yeah, really quickly, especially like the struts themselves. Yeah, the wheels are really neat. If I hide some of those parts, though, let's just get the struts.
Now I want to go break out my TPU and print them in rubber.
I know. I thought about that. That would be really good. There we go. There's some of the struts.
Gotcha.
So I've added. You can see I've added like some just decorative things. But the originals took a minute to model. It's 2 circles with a line in the middle of them. And I printed those and I put them in there and I figured out how to get the spring to fit. Figured out how to get, these are going to be M4 screws that go in there.
Excellent.
So those act as the axle for these struts. And again, I did all that on a small prototype. The pieces these struts, they took minutes to print.
And the moment you actually have figured out that the one you took minutes to print works, then you can add side details to it that don't interrupt its functioning and give you all that detail.
So, for example, I'm glad you mentioned that. Let's turn our wheels back on here.
Did this get in your way?
So I originally put this detail here down on the bottom.
Right. Oh.
And for some reason my brain said it was going to be the opposite. But when the wheel moves up, that thing cambers down and would intersect that. So I just redrew that and put it up on the top. It doesn't really matter where it is.
This functionality really thrills me because I have this picture in my mind of this little droid of like 6 of them, like.
Oh, yeah.
And then like coming to an obstacle and like one of them peeking over and then going back down again.
Yeah, with his one big eye. I love it. So the wheels, let's talk about the wheels.
Okay.
Because that was the second challenge. I got the struts figured out and I got the suspension figured out. The wheels, a few things. One, I wanted to try and print stuff with as little support material as possible.
Right.
There were a couple of pieces like the chassis that just kind of need it. But the wheels, I split these in half.
So that you could absolutely not have any support material.
Right, and I put pins in there to locate them, so we'll glue them together.
And so they go on either side so that they can rotate on the hub.
Exactly. So the hub screws together and pins the wheel between it, and it can spin between it there. So that's what's going on under there. The hubcaps are threaded. There's a big thread around there, so that we can put our screws in, attach the struts,
and then just back out.
Just slide it on there. Now a little secret, because a little press for time.
Yeah.
The left wheel is a left-handed thread, and the right wheel is a right-handed thread. Because once this was done, I just mirrored the whole thing over.
That's wonderful.
So when you're putting it together, if
you can't put it together wrong.
It's true. You can't. You absolutely can't.
That is really cool.
I thought that was a creative way to solve that without needing any hardware. And you can remove it very easily.
Dude, this is a super cute little bot.
Isn't it?
I have a lot of affection for this guy.
Yeah, me too. It's got a lot of personality.
One of my favorite parts about this process is I texted you some of these pictures up to your house in Seattle.
Yeah.
And I think within like 4 hours, you sent me back a text link that didn't show me a drawing. It actually gave me access to a full 3D thing that I could spin in my phone.
Yeah, right on your phone, right in a web browser too. You don't even need the app.
Blew my mind.
One of my favorite things, because a lot of times if I'm doing this kind of work for someone else, it's over a distance, and I can say, just tell me what you think. Look at the whole model. You can from the web browser, you can hide parts.
Yeah.
You can leave notes. It's really handy for collaboration.
It collapses that distance to nothing in a hurry.
And then I got notes, and I was like, got it. I'll have it done tomorrow.
Yeah, the next morning we had the full set of files. Amazing.
Oh, it's so much fun. I love this kind of work. I went to school for 3D computer art, and sitting in front of a computer modeling stuff is my happy place.
Oh.
This was actually another fun note that you have. So this afterburner that you have, his little propulsion, you said, well, could we add some 1/8" holes for tubes?
Yeah.
So I just covered this thing in 1/8" holes. You can see these holes here.
Nice.
So that later on you can connect these to wherever you want to go.
I just thought some silver solder pipes and tubes and stuff disappearing in the back would add some great detail.
And fill this this cavity here with a little bit.
Yep. Yeah. So we can kit bash the inside of that.
Totally.
Dude.
This was fun.
Okay.
This was really fun.
So the next step now, this set of files, how many separate parts is this? Like,
that's a great question.
20, 30?
20, 30, yeah, sir.
So the next step is to send these to the printer.
Printer, and it shouldn't take that long too. These are not that big of parts.
We got a couple of 3D printers here. I think 4 or 5.
That'll
like
do.
That. Yeah, that'll do.
Let's fire them up.
When you see us next, we'll have parts.
Yeah.
Dude, we got some old parts.
We got parts. Norm printed a bunch of these, and we can start putting them together. This is my favorite part.
This is really, really, it's a lovely reality. Look at that wheel.
Yeah, so they are a pair. You can see there's an extra sort of lip on this. That's where it engages with the hub.
Ah, okay.
So these two are a pair, and those two are a pair.
All right.
So why don't we start by putting those together?
Okay. I got 3 little. Oh, nice tolerance fits.
And so I had to decide if I was gonna use like nuts for these screws or just have them thread straight into the print.
Right.
And I decided to go straight into the print because less pieces.
So you're no threaded inserts. You did an interference fit that can go right into and sort of carve its threads in. How do you determine? Do you have a base value for that that's written on posted on your desktop, or do you figure it out for each print?
I have that too, but I printed out this little test here with various diameter holes, so that I could take the screw and figure out which one would be a good one for cutting its own thread and which one would be good for clearance.
Amazing. It's funny, I used to do this all the time at ILM on the laser cutter.
Yeah.
Because extruded acrylic is never the same thickness in any specific part of the sheet. So yeah, I had to do lots. This is really cool.
So I actually started designing this with M3s. Realized I had to scale it up a little bit, so I did that one for M4s, so I had it all figured out.
And you even brought your own M4s?
I did. I'm sure you have your own, but there we go.
Okay.
And then that should stay, and we'll get a screw in there.
Oh, nice! And so you've made the fit on the other side of that hole.
Yep.
An interference fit. So
now we have.
Bill.
There we go. So each side has its own spring.
That is really cool.
It's pretty satisfying.
I really dig how simple that is.
Yeah, so I've been doing a lot of my own 3D printed mechanical designs, and learning. Does it go that way or that way? That seems fine. Learning about how to design for 3D printing in a way that usually doesn't use supports if I can avoid it, but also ways I can be creative with the process. So like the details on the front and the back is flat.
Right.
And that was just a really quick way to do that.
So it sits nice and flat on the bed.
There we go.
I must say, the relationship you got between all of these slightly different compound curves is dead on the money.
Awesome. That makes me happy. So let's see. Why don't we do that next?
Okay.
Here, this is fun. All right, let's get.
So yeah,
take this piece.
Yeah.
And slide it into the back of that piece. There you go.
Oh.
And it just snaps in place.
That's sweet.
So if you flip it over, you see these two little tabs. Just grab it. And then this part here gets attached to that. So I split this up for printing, so they can print in that.
Right. Again, no supports, and then the panel line is your print base.
Yeah.
Brilliant.
So this
sits
goes
in
through there.
Oh, and is that an interference fit for the M4s?
That yes, that one is. And I also added
Oh, a little alignment
this just
tab.
to locate it. Yeah.
Sure.
Oh, yeah. So, just about everything in this is an M4 by 10 millimeters.
Can I pay you some deep respect for how beautiful that pen line is?
Isn't that great?
How much it matches the others exactly.
You can't even tell.
I mean, I look at this and I don't feel like I'm looking at two separate parts. That's what's so pretty about that.
Success.
Dude. Okay.
All right, this guy can go on there next. There's another locating pin there, and it only has one screw. Same thing. You've got the.
Dude, I can't believe how much. I literally was thinking that you.
Other way.
That you were going to show up with a static model, because I was like, there's not enough time for him to make it actually mechanically functional. You have exceeded everything I imagined was possible. Yeah. Also, it's really nice, this interference fit. It's not too resisting, and yet when you bottom out, you feel it, and it's nice and tight.
Yeah, and that's the difference between doing this 4 millimeter hole and a little bit smaller. This was too difficult.
And when you are sizing those holes for filament printing, are you adjusting each hole by like 1/10 of a millimeter per hole?
That's about what this is, M4, M4.1, 4.2, 4.3.
Okay, right. So it's about 3/4 thou difference per.
And it's amazing how much of a difference it makes. Because this is clearance. This is absolutely not.
That's really cool.
Difference of 0.1 millimeter in diameter.
Dude.
Okay.
Look at this little handsome boy. All right.
Which one of these is left and which one of these is right? I think this one goes there. And yeah, that's correct.
All right.
Now these should be, here I'll do one just to confirm my
there's an interference fit on one side and a clearance on the other?
So that can go.
You sexy beast.
Uh-huh. Yeah.
I'm going to do the other one?
Absolutely.
All right. It's funny, you know, I really appreciate the channels where people work everything out in CAD. And don't get me wrong, when I worked at ILM and I was CADing stuff, like the whole goal was design it and draw it once.
Yeah.
Which never occurred.
No.
But like I really appreciate this iterative approach to getting these fits to be really tight, because.
And it's not theoretical. This is very practical. Because I bet if I measured this 4 millimeter hole here, what was in CAD drawn as 4 millimeters, it's not 4 millimeters.
Right.
There's some shrinkage, some variance.
It's about what the machine is actually cutting, not what the machine even thinks it's cutting. Yeah. Bill.
Look at that.
That is some sweet business.
So the wheel, I'm rather proud of how this turned out here. The wheels, there's a groove if you screw those together. So I've threaded these. Now that might be the wrong size.
No, I think I managed to get it. Wait. That's
a left-hand thread.
All right.
That's the right-hand thread. There you go.
What?
See? And now there's a groove between those two parts that matches this.
Oh,
here,
no. So we put the tire on. And then this just
zips right on. There's enough clearance to spin the wheel. Yeah. Right?
Dude, I am so blown away.
And of course, I did that, of course, so that we can get at the, the hub there if we need to fix it or anything.
Right, and you are prioritizing mechanical access to fitment.
Yeah. Well, that.
Yeah, no, I know it balances quite well. It's quite stable.
I love having the registration pins too, because then I know everything's lined up when I go to screw it in.
It's really nice, and I like that they're not integral. That you add them, you don't have to have them. I appreciate you letting me do all this assembly, Bill.
I love putting the kits together. It's one of my favorite things about 3D printing. I get to make my own model kits and toy kits.
Okay, there's that.
And then this part does get glued on. I got to a point where I was like, we're just gonna glue that.
Fair. And it's
other way.
That
there
way.
You go.
All right. Excellent. We'll let that sit there.
And then the eye gets glued into
a little shroud.
And then that gets glued into the front. There he is.
Bill! Wait,
There's
wait,
our
wait,
little-
wait, wait, wait. We need a antenna. Let me see here. I want to do. Something like that.
Mm-hmm.
Yeah.
Something that makes you think speed.
Exactly.
It's a quick little guy.
And then, yeah, just like a little doink doink on this guy. Oh, wow, that's one still. Dude! All right, Bill. That makes me so happy.
Yeah, you just drew that like 4 days ago.
It's amazing that it's just a few days later and we're looking at a completed piece.
And there's tons of room for after printing. You could customize it in so many ways. You can add the hoses if you want. This is now a platform.
Yeah. Oh man, that is super, super cool.
If we cooking show it, I've got another one right here.
Oh, look, you made. Oh,
my
you went with some
prototype.
accents. I love it.
We've been doing more printing with lots of different colors, so I've been really enjoying that. This copper I like a lot too, just throwing a little different metallic back
I'm
there.
noticing a lot of that ethos out there among the printing is like the different metallics. And it's really, there's some lovely effects you can get.
Some fun ones you can pick from, yeah. There we go.
That is even though we got this call to do this thing and we knew, we were going to play, I didn't realize, despite your and my expertise, that this would be this much fun and this easy to do.
It was incredibly fun.
Yeah.
I got to spend a couple of days modeling this, doing my test prints, running up and down my basement stairs. And every time a print comes off the bed, it's like Christmas morning.
Yeah,
And I get to fit it. It's been a real treat. Thank you for inviting me to play on this project.
My favorite part of this project is actually getting to see a little bit more of the inside of your engineering mind, which never ceases to really impress me, my friend.
Cool, thank you.
It's a delight. So you guys can submit your own designs at autodesk.com/droid for a chance to win either many prizes, including a chance to visit Lucasfilm here in San Francisco or the Walt Disney Studios lot in Burbank. Make your droids, submit them now. And make sure to watch the first 2 episodes of The Acolyte premiering on Disney Plus on June 4th. Yeah.
Mm.